Right.
And what I love about this entire discussion is that maybe not every single one, but a lot of these ideas actually stem from the simple observation that the speed of light is constant. Because I actually read this on Wikipedia, not my words, but the speed of light is the conversion factor from space to time, or from time to space. And so if you have if you have a constant and it's equal to, like, this is just an example, to get your brain thinking. But if you have a constant that is equal to, let's say, x times y, just two numbers being multiplied by each other, because you know that those are equal to a constant, then if x goes up, y has to go down. And if y goes up, x has to go down. Like, they're related in that way, you know what I mean? And so, for example, because we know that the speed of light is constant, it's almost like, the faster you go, the slower you experience time. And, also this is just some special relativity stuff, but it's kind of like, you always have to keep in mind that the thing that stays constant is light, and then the space and time is what bends in a way that whichever frame you're in, light will always stay that constant speed, right? And the beautiful thing about this is that it's all observer dependent, right?
You're right.
Because, like, living in a universe and being the fact that a universe exists and having observers within that universe is kind of synonymous, right?
Yeah.
If you have a universe with no observers in it, then does it really exist? Right? It's kind of up in the air, because
you're right.
There's nothing
it's that classic
in it
philosophical question. You're right.
Exactly. It's pretty philosophical. Yeah. But, like, for example, like, my idea is actually getting a little bit philosophical.
No, let's hear it. Why not?
No, I was gonna say, like, for example, if I look out into space and I see like a certain effect of, like, special general relativity, would that effect still be a thing if nobody was there to see it? Like, this question doesn't really make sense. But
yeah, because, like, I mean, it's that classic question, right? Like, if a tree falls in a forest, is like, did it really fall kind of question.
But would the laws of physics,
and there's no observer kind of
even
thing,
exist, right? Because special relativity depends, and general relativity, it depends on the frame, right? And it depends on who's looking. But if there's nobody looking, then, like, what do you?
Then it doesn't make any point. I mean, then there's no point, though, because if no one's looking, you're not really. You don't really care about the system. So then, I mean, it's kind of like it's kind of like a, I mean, it's not a tautology, but it's kind of like a circular thing, because, like, that doesn't make any sense.
Contradiction.
Yeah, kind of like that kind of vibe, So I mean, I'm not sure how true that is, but the biggest difference, though, because
I don't know, I'm just bouncing ideas.
Yeah, no, but the biggest difference that you were talking about special relativity, and I mean, we have mentioned this previously before, but because we're talking about it, in this episode, we obviously have to. Special relativity versus general relativity, the biggest difference is that in special, you can literally think about it like a special case. It's a special case. The special case is when the frame of reference that you're in is inertial, meaning that, and we've spoken about this many, many, many times, that means the frame is, like, not accelerating, or it's traveling at constant velocity, or it's at rest, or something like that, right? So basically the frame is, so it's an inertial frame of reference. So that's your special case. Then we get general relativity, which is your general case. So that could be even accelerating frames of references. And that's actually where it pioneers, right?
Things get very complicated very quickly.
Oh, for sure. Because it's mainly because of the math, right? It's mainly the math required for general relativity is of a higher level, for sure, 100%. So it's just, it's a lot of combination of a lot of things. And I think we're going to touch on to some of it. Like the field equations, I know, like, we had that plan to just talk about it a little bit, so I'm gonna get into it. But it's really crazy, and it can definitely get exponentially harder, man.